Take an ordinary deck of cards, 52 cards, shuffle it. The order you're now holding has, almost certainly, never existed before in the history of the universe. Not once. Not in any casino, any card game, any shuffle by any human who has ever lived. You just created an arrangement that is, with near total certainty, brand new to reality. That sounds impossible. It's a small deck. But it's true, and it's your first step onto a staircase of numbers that climb so fast, so violently, that within a few minutes we will reach a number so large the entire universe physically cannot contain it. Not would take a long time to write. Cannot contain it. There is not enough room in all of existence to hold the digits. Let's climb. Start with that deck. How many ways can you arrange 52 cards? You multiply 52 times 51 times 50, all the way down to 1. Mathematicians write it as 52 with an exclamation point, and they call it 52 factorial. The answer is about 80 unvigintillion. Written out, it's a 68-digit number, and 68 digits doesn't sound like much until you try to feel how big it actually is. Here's one way. Imagine you could shuffle a deck and lay down a new, unique order once every single second. Now imagine you'd been doing that since the Big Bang, 13.8 billion years ago. You would not be close. Not 1% of the way, not 1/1,000th. To get through every arrangement, you need to do it for vastly longer than the universe has existed, trillions of times over, from one little deck of cards. That's the first lesson of this staircase. Numbers don't grow the way our intuition expects. They explode, and we are still standing on the very bottom step. Let's go up. You've probably heard of a googol. A googol is a 1 followed by 100 zeros. It's a famous number, the one a certain search engine is named after, slightly misspelled. And a googol is genuinely enormous. It is far, far bigger than the number of atoms in the entire observable universe, which is only about a 1 followed by 80 zeros. So a googol already outnumbers every atom in every star, every planet, every galaxy we can see with room to spare. Sit with that for a second. We have already, on the second real step, named a number bigger than the count of all the atoms in the visible cosmos. And we have barely begun. Because next comes the googolplex. A googolplex is a 1 followed by a googol zeros, not 100 zeros, a googol of them. And this is where the universe starts to break. You could not write out a googolplex. Not because you'd get bored, because it is physically impossible. If you tried to print all those zeros, 1 0 per atom, you would run out of atoms in the observable universe long, long before you finished. There is not enough matter in everything we can see to hold the written form of this single number. The number itself is a perfectly ordinary, finite number. You can define it in one sentence, but its full written body cannot exist inside reality. And here's the thing you need to feel before we take the next step. The googolplex feels like the edge of imagination. It feels like the top. It feels like we've reached the ceiling of how big a number could possibly be. We have not even started. Everything so far, 52 factorial, the googol, even the impossible googolplex, all of it is about to become so small, so insignificant, that compared to where we're going, it rounds to 0. It is nothing. It is a rounding error on a rounding error. To go further, we have to leave normal numbers behind, because normal notation simply gives up. You can't write the next number with digits. You can't write it with exponents stacked into towers. Mathematicians had to invent an entirely new kind of arrow notation just to talk about it. And the number they built with it has a name. Graham's number. Graham's number came out of a real mathematical proof, a serious problem in a field called Ramsey theory. This isn't a number someone invented just to be huge for fun. It showed up as the answer to an actual question, which somehow makes it stranger. And it is so large that it makes the googolplex look like the number 0 by comparison. Now I need you to understand just how completely it defeats the universe. With the googolplex, we said you couldn't write the digits because you'd run out of atoms. With Graham's number, it's worse, and it's worse in a way that should genuinely stagger you. Suppose you shrank each digit down to the smallest possible size that physics allows, a unit called a Planck volume, the tiniest meaningful pocket of space that can exist. And suppose you filled the entire observable universe, every last Planck volume of it, with digits. You would not even come close to holding Graham's number. But it goes deeper. Even the number of digits in Graham's number is too big to fit in the universe. And the number of digits in that number is too big. And the number of digits in that one. And this keeps going. Layer after layer after layer, more times than there are Planck volumes in the cosmos. The universe can't hold the number. It can't hold the size of the number. It can't hold the size of the size for a stack of sizes longer than the universe itself could ever measure. And yet, here is the part that breaks your brain in the other direction. Mathematicians know exactly how Graham's number ends. We have calculated its last digits. The final digit is a 7. We know the last 500 digits precisely. We know the ending of a number whose beginning, whose middle, whose entire body could never exist inside reality. We are holding the tail of a creature whose head is bigger than the universe. You'd think that would be the top of the staircase, the biggest number that ever mattered. It isn't, because there's a number that makes Graham's number look like 0. Truly, genuinely 0, the way Graham's number makes the googolplex look like 0. It comes from a deceptively simple game about drawing trees and dots, and it's called Tree of 3, Tree 3. For years, Graham's number was the largest number ever used in a serious mathematical proof, famous enough to land in the Guinness Book of World Records. And then Tree 3 appeared in real proofs and crushed it so completely that next to Tree 3, Graham's number is indistinguishable from nothing at all. Mathematicians can prove Tree 3 is finite. They cannot even tell you how many digits it has. We don't know. It is a finite number whose size is beyond our ability to describe even loosely. And above Tree 3 are larger numbers still. There is no top. The staircase never ends. For every unthinkable number, there is another that makes it vanish into a rounding error forever, with no ceiling, no final step, no biggest number, because you can always add one. So step back and look at the whole climb. We started with a deck of cards in your hands, a number so small it fits in 68 digits. And within minutes, we passed the atoms in the universe, then the matter to write a googolplex, then a number the cosmos cannot physically contain at the finest grain of reality, and then a number that makes that one disappear. And the strangest, most beautiful part is this: none of these numbers are infinite. Every one of them is finite. Everyone has an exact, specific value. They are not vague, not endless, not infinity. They are particular, finite numbers sitting at definite points on the number line that are simply too large for the physical universe to ever hold. And the strangeness lives here, in the finite, in numbers you can name in a single breath that are nonetheless too vast for all of space and time to write down. The universe has a size. Reality has a limit. And the numbers blew past it without slowing down. But sit here with me for the last minute, because there's something underneath all of this, and it's softer than the numbers. And it might be the part that stays with you after you've forgotten that the last digit is a 7. Look at what just happened. A number too enormous for the entire universe to physically hold. A number that would collapse into a black hole long before you finished writing it. Just passed through your mind. Quietly. In a few minutes. While you were sitting still. You didn't hold all of its digits. No creature ever could. You held something the universe itself can't seem to hold. You held the meaning of it, the shape of it, the awe of it. Think about how small you are against these numbers. You are a flicker, a rounding error on a rounding error on a rounding error, gone almost before you began. By the scale of what we just climbed, your entire life, everyone you love, every person who has ever lived, all of it barely registers. That can feel cold. It can feel like it makes you nothing. But turn it over gently and look at the other side. The numbers are bigger than everything, and they don't know it. Graham's number will never feel the vertigo of its own size. Tree 3 will never gasp. The galaxies that cannot contain these numbers will never look up in wonder. But you did. You, the small, warm, finite thing, are the part of the universe that woke up, did the math, and felt something. The cosmos assembled something out of stardust that could turn around and comprehend the very limits of the cosmos. That's you. That is what you are. So no, you are not big. You are never going to be big, but you are the place where the universe finally gets to understand itself, even just a little, even just for a few minutes on an ordinary night. The enormous things can't fit inside reality. And yet tonight, somehow they fit inside you. You are small, you are brief, and you are the only thing in this entire story that ever got to be amazed. That's not nothing. That might be the whole point.